Good morning, dear students. Okay. So in the previous class, we were discussing the methods of preparation of carboxylic acid, right? So we have discussed some 3 or 4 methods of preparation. So these were the methods of preparation which we have seen in our previous class. So first was from primary alcohols and aldehydes. Okay. So by taking the different oxidizing agents, so for primary alcohols, so these are the different oxidizing agents, and for the aldehydes, so these are the oxidizing agents which we can use for conversion of aldehydes into carboxylic acids, and this which we can use for conversion of your primary alcohol into carboxylic acid. So based on this, we have discussed the general reaction as well as the examples on this. Okay. So secondly, then we are discussed about the second preparation, that is from alkyl benzene. Okay, from alkyl benzene. That is when you have a aromatic carboxylic acids. Okay, so aromatic carboxylic acid can be prepared by this particular method where you can have a alkyl benzenes. Okay, alkyl benzenes means what? You have a benzene ring and an alkyl substitute, right? So from alkyl benzene, you can prepare your what? You can prepare your aromatic carboxylic acid. Okay, aromatic carboxylic acid. So what is the medium? What you are going to use? Either you can use bromic acid, okay, or you can use acidic or alkaline potassium permanganate. So these are the oxidizing agents which you can use. We are going to do oxidation. So first it is going to convert into its salt form, okay, in its carboxylate form. So here it has formed sodium, potassium benzoate, okay, potassium benzoate is formed. Then further hydrolysis, you get a benzoic acid. Then in second example, you can see there is a long chain of alkyl group. Okay, you have a propyl group. So irrespective of how many carbon atoms are present in the in your side chain, okay, so this is going to convert into a carboxylic group. Okay, that is a C double bond O. So you can read this, the entire side chain will be oxidized to the carboxyl group irrespective of the length of the side chain. How many carbon atoms are there, that we are not going to see. Okay, so everything is going to convert into a carboxylic group. Okay, COO minus group. And further, when you do hydrolysis, you are going to get the carboxylic acid. Okay, so it is a benzoic acid again. So this also we have discussed previously. So these are the preparations. Next, we had discussed from nitriles and amides. So if you do hydrolysis means what? So I have a nitrile group. So nitrile means what? You have C triple bond N. So I'm going to add what? Water. Okay. So here H2 here and oxygen here. So I'm going to get from nitriles, I'm going to get what? Amides. So from nitriles, after performing the hydrolysis, I'm going to get what? After doing hydrolysis, I'm going to get amide. This amide in the presence of a catalyst like H plus or OH minus, I'm going to get what? I'm going to get a carboxylic acid. Okay, so this is also another preparations, okay, wherein you can prepare your carboxylic acid. So please remember these all methods of preparations. Okay, fine. Next, okay, and directly from amides, how you can convert. So if you have a amide, okay, and I want to do it as an acid. So what I can do, I can use a H plus or OH minus as a catalyst. Okay, I can use H plus or OH minus as a catalyst. Okay, if I heat it in the present, so if I heat my amide in the presence of H plus or OH minus as a catalyst, I'm going to get what? Benzoic acid. Okay, I'm going to get what? Benzoic acid. So from nitriles also it can be converted into carboxylic acid. The intermediate will be a amide. Okay. And directly from amide, you can convert into carboxylic benzoic acid. Okay. That is your respective carboxylic acid. So like this, from nitriles and amides also you can prepare your carboxylic acid. Okay. Next is from Grignard reagent. From Grignard reagent. Okay. So from Grignard reagent. So previously in the previous class, I had asked you, what is Grignard reagent? Yes. So it is a organometallic compound, right? So organometallic compounds are called as Grignard reagent. And how it is represented, students? Yes, how it is represented? It is represented as RMGX, right? It is represented as RMGX. So what is a Grignard reagent? Grignard reagent is a organometallic compound. And how it is represented? RMGX. So let us see the methods of preparation. The next one, okay, that is from Grignard reagent. So what we are going to do, we are going to take a Grignard reagent. Okay, I'm going to take a Grignard reagent and I'm going to treat it with carbon dioxide. Okay, I'm going to treat it with what is dry ice? Okay, the other name of dry ice is carbon dioxide gas. Okay, so carbon dioxide, so remember this also. So carbon dioxide gas is called as dry ice. The other name is dry ice. So if you treat your Grignard reagent with dry ice, it forms a salt of carboxylic acid. It forms a salt of carboxylic acid. Okay, like this. So it forms a salt of carboxylic acid. This further upon hydrolysis, okay, if you do a acidification, okay, you are going to get a what? Carboxylic acid. You are going to get carboxylic acid. So remember these, how to react it with the Grignard reagent. So we are going to take Grignard reagent. Okay, let me write and show you. So let me take a Grignard reagent. Okay, RMGX. Then I'm going to react it with what? Dry ice, that is carbon dioxide, CO2 gas. Okay, so this is dry ice in the presence of dry ether. Okay, in the presence of solvent like dry ether, I'm going to get a salt of carboxylic this. So that is MgO minus MgX, X minus. So this further upon hydrolysis, you are going to get what? R C double bond OH plus MgOH and X. Okay, so this is the reaction. So this is the reaction. Okay, this is the reaction where you're treating your Grignard reagent with dry ice. Okay, in the presence of dry ether, you're going to get what? You're going to get a salt of carboxylic acid. You're going to get what? Salt of carboxylic acid. You're going to get what? Salt of carboxylic acid, which on acid hydrolysis will give you carboxylic acid. Okay, so let us take an example now. Okay, let us take an example. So I'll take R as CH3 Mg iodide, okay, X as I, plus react it with carbon dioxide. Yes, I want the answer now. Yes, try answering this. So what will be the answer? How
CH3
CH3 C,
single bond C
yes,
double bond O
yes,
single bond MgI
O, O minus
O
Mg,
minus MgI.
yes, then Mg plus. Right, okay. Then further hydrolysis will give you what?
CH3 C double
Is
bond
it?
O OH plus
Yes,
MgI.
MgOH and okay, very good. So this is the product of. So here we are going to take what? Methyl magnesium iodide. So the name is methyl magnesium iodide. So when you treat your methyl magnesium iodide with carbon dioxide gas, or you can call it a dry ice, okay, in the presence of dry ether, I'm going to get, this is the acetic acid. Okay, acetic acid. So this is the reaction. Is it clear?
Yes, ma'am.
Okay. Others, what about others? So another, so we have seen four preparations. So next is from acyl halides and anhydrides. Okay. Next preparation is from acyl halides and anhydrides. What is a acyl halide? R C double bond O Cl. So this is your acid chloride, or it is called as acyl
Acyl.
chloride. Okay, so this is the acid chloride or acid and acid acyl chloride. Now, what is acid anhydride? Okay, so this is your acetic anhydride. Okay, so this is your acid anhydride. I'll write it as acid only. Okay, so I have taken R there. So it is a acid anhydride. Okay, so R can be your any alkyl group or a aryl group. R can be your any alkyl or aryl group. So this is acid halide, acid chloride. Okay, so I have taken Cl. So it is acid chloride. If I take R C double bond O X, so it becomes what? Acid halide. It becomes acid halide. Okay, halide can be anything then. X can be your Cl, Br, iodide, like that. Okay, so most commonly we take chloride only. So we represent it as acid chlorides. So acid chlorides or acyl chlorides, and this is acid anhydride. So let us see the preparations from acyl halide first. So acyl halides, when you treat it with water, okay, what we are doing? We are doing hydrolyzed. Okay, we are hydrolyzing it with water. I'm going to get what? Carboxylic acid plus HCl. Okay, so your Cl will be replaced by OH. Your Cl will be replaced by OH, and your Cl will be, so H2O. H2O will split into H plus and OH minus, right? So your OH minus will attack here, and whatever H plus is left, your Cl minus from here will combine with this. So you get HCl. Okay, you get what? You get HCl. So this is the reaction. Understood? So your acid chloride, it undergoes hydrolysis. So water, okay, it splits into H plus and OH minus. So OH minus is the nucleophile. So it gets replaced by Cl. Okay, and H plus ion will get combined with the Cl and you get HCl. Okay, so this is one method. So acid chloride when hydrolyzed with water will give you carboxylic acid, or more readily hydrolyzed with aqueous base. So, or you can do what? You can do a hydrolysis with a base. Okay, so we are performing your base hydrolysis. Base hydrolysis means what? Okay, you're adding water, but in the presence of a base. Okay, any base like NaOH base, KOH base. So, what will be your nucleophile here? OH minus. Okay, so what it forms? It forms a carboxylate ion. Okay, RCO minus, that is carboxylate ion, plus Cl minus, which upon hydrolysis, okay, you are doing acid hydrolysis, you are doing acidification, you can write, or you can write acid hydrolysis to give you what? You are going to get a acidification. Okay, we are doing acidification, we are supplying H plus ions, we are going to get carboxylic acid. So this is bit tedious process. Okay, here directly our Cl minus is replaced by OH minus. In base hydrolysis, what is happening? It is first converted into a carboxylate ions. Okay, it is converted into carboxylate ions plus Cl minus. These carboxylate ions, upon acidification, you are going to get what? We are going to get the carboxylic acid. Okay. Now let us see examples on this. Let us see examples. So first example on this particular this. So CH3, C double bond O, Cl in the presence of water. Yes, tell me the answer. Second one. Yes, first one, what is answer?
CH3 single bond C double bond O single bond OH
Yes, what is
plus
the name?
HCl.
What is the name? Name of the compound? Acetic acid. Okay, acetic acid. CH3COOH is what? acetic acid. Okay, it is acetic acid. So the name of the compound is acetic acid. Okay. Now again, same by this method, same we can do our anhydrides also. I told you what is anhydride. So C double bond O R C double bond O. Okay, so this is our anhydrides. Okay, acid anhydride. So this again in the presence of water, what we are going to get? So here, what will happen here? Yes, here again. So there are two molecules. So you are going to get R C double bond O OH. Okay. Okay. So this you are going to get R C double bond O OH. So same, if I give you example here, so here you can take C6H5, okay, C double bond O, then C6H5, C double bond O. Okay, if I treat it with water, what I'm going to get? So across this, so here also, so this oxygen is common to both. So you're going to get what? I'm going to get C6H5 C double bond O OH plus C6H5 C double bond O OH. Okay. So I'm going to get two molecules. So I'm going to get what? Two molecules of your this. Got it?
Ma'am,
C6H5.
we can write 2C6H5.
Ha. Yes, yes, you can write 266H5 C double bond O OH also. Now you tell me this answer, okay? C6H5 C double bond O CH3 C double bond O. Okay, now this in the presence of water. So we are doing hydrolysis now. How what you are going to get? So this is our benzoic, ethanic, anhydride. The previous was benzoic anhydride. Yes, what will be the answer for this?
C6H5. C6H5 single bond C double bond O single
Hmm.
bond OH plus CH3 single bond C double bond O single bond OH.
Yes. So one is your what? One is your benzoic acid, the name of the compound. Okay. And another is acetic acid.
Acetic acid.
Yes, very good. Okay, so like this, you have to give the products. So from acyl halides and from acetic and from your acid anhydrides, you're going to get these products. Okay, you're going to get these products. Okay. So next is from esters. Next is from esters. So esters, what you can do here? So as when esters are there, so these esters will undergo acid hydrolysis. Okay, we are going to do acid hydrolysis to give you directly the carboxylic acid. To give directly what? Carboxylic acids. Okay, while if you do base hydrolysis, so if you have acid esters and if you do base hydrolysis, okay, we can do base hydrolysis also, but what will happen? You will get carboxylate ion. You will get carboxylic ion. This again, what you have to do further, acidification. You have to supply H plus ions and then you are going to get carboxylic acid. Okay, you are going to get carboxylic acid, acidification. Fine. So here, so what you're going to do, so suppose I have first one. Okay, if I take a ester like CH3, CH2, CH2, C double bond O, C2H5. So this is my ester. So ester, I'm going to do what? I'm going to do acid hydrolysis. Okay, if I have acid hydrolysis, what will happen? Directly, I'm going to get what? CH3, CH2, CH2, okay, and COOH plus C2H5OH. Got it? So here, what I'm going to get? Here itself, I'm going to put H plus ion, and here I'm going to put OH minus ion. Okay, so water. So water will, so here H plus, here OH minus. So in the presence of what? Acid hydrolysis. So this is in the presence of acid. So this is undergoing acid hydrolysis. So next, if I have a base hydrolysis, if I have a base hydrolysis, suppose the same I'll take CH3, CH2, CH2, C double bond O, C2H5 plus add water in the presence of OH minus. Okay, means what? It is undergoing what? Base hydrolysis. Okay, it is undergoing base hydrolysis. What I'm going to get? Yes, I'm going to get carboxylate ion. Okay, so how it will be? CH3, CH2, CH2, C double bond O minus plus C2, okay, plus okay, this only will do first. Then further in the presence of H plus ions, that is acidification, I'm going to get what? I'm going to get CH3, CH2, CH2, C double bond OH. Okay, so this is your, again, the product. So this is what? Butanoic acid. I'm going to get what? Butanoic acid plus here I'm going to get what? C2H5. Okay, and C2H5 plus it will be. So OH minus will attack and you're going to get what? C2H5OH. So ethanol. Okay, and ethanol. So like this is the product. Okay, this is the product. So with base hydrolysis, you are going to get what? Carboxylate ion. First, you are going to get a carboxylate ion. This carboxylate ion, further acidification, you are going to get the respective acid. Is it clear? Is it clear?
Yes, ma'am.
Okay, now here also you see. Okay, so here I'm going to get H and here I'm going to get OH. So what I got here, COOH and C2H5OH. Okay, so this is our benzoic acid. What is the name? This is benzoic acid and this is our ethyl alcohol or ethanol. Ethyl alcohol, ethanol, and this is ethyl benzoate. This is ethyl benzoate. Okay, got it? Fine. So this completes our methods of preparation. Okay, so let us see the physical properties now. So physical properties. Okay, so all the aliphatic carboxylic acid up to 9 carbon atoms are colorless liquid. So the aliphatic carboxylic acid up to 9 carbon atoms. Okay, up to 9. So that is C1 to C9. So these are all colorless liquid. Okay, they are colorless liquid at room temperature. Okay, and they have a very unpleasant smell. Unpleasant odor means very dirty smell, not good smell. Okay, so very what unpleasant. Unpleasant means what? It
Ma'am,
the
pungent smell, ma'am.
yes, pungent means you can pungent is a particular smell. Pungent means what? It will be like something is rotten. Okay, something is rotten like that. That pungent smell will be okay. For example, you might have taken the ammonia smell, right? How does ammonia smell will be like urea. Okay, like urea smell. So pungent is different. Unpleasant means these all will be having some different smell, very different smell. Okay. Then the higher acids, if so up to C1 to C9, they are colorless, okay, at room temperature with very bad smell. And then the higher acids, okay, after this, up suppose C10 onwards, they are wax-like solids. They are wax-like solids and are odorless. Okay, they does not have any smell, odorless. Why? What is the reason? Due to low volatility. Okay, due to low volatility. So this is about your physical state, how they appear, how they smell. Okay, next is boiling point. So carboxylic acids are having the highest boiling point among all the functional group in organic compounds. So as we have seen hydrocarbons, okay, you might have seen this alcohols, right? You have seen phenols, okay, you have seen ethers, okay. So of all this, when you are comparing, then you have seen aldehydes, ketones, okay. So of all this functional group, your carboxylic acid, okay, your carboxylic acid group is having the highest boiling point. Is having what? It is having the highest boiling point among all the functional group. What is the reason? What is the reason? It is due to intermolecular hydrogen bonding. Okay, it is due to the intermolecular hydrogen bonding. You can see. So if there are two molecules of, so this is one carboxylic acid, and suppose if I write one more carboxylic acid, okay, so this is another. So you can see they can form the intermolecular hydrogen bonding, right? So they can form dimer, okay. So you can see that most of this carboxylic acid, they exist as dimer in vapor phase. So in their vapor phase, they exist as dimer, okay. So, so this is about the boiling point. This is about boiling point. Let us go for the next one. Next is solubility. Next, we are discussing about the solubility. So what is solubility? So when we are discussing about solubility, so the aliphatic carboxylic acid up to 4 carbon atoms are soluble in water. So from C1 to C4, okay, they are soluble in water. Okay, miscible means soluble. Miscible. What is the meaning of miscible? Miscible means they are soluble in water. Miscible means soluble in water. Okay. Why? What is the reason why they are soluble in water? It is due to formation of hydrogen bonds with water. Okay, it can form easily hydrogen bonding with water. So because up to C1 to C14, they can be easily soluble in water due to formation of hydrogen bonding in water. Okay. Now, what happens after C4? Okay, so as the number of carbon atom increases, okay, solubility decreases. So as the number of carbon atom increases, solubility will decrease. The solubility decreases. So higher carboxylic acids are insoluble. They are practically insoluble in water. Why? What is the reason? Water. Okay, they are insoluble in water. What is the reason? It is due to hydrophobic interaction of hydrogen part. Okay. Now, what will happen as there is more as the number of carbon atom increases? Okay. So the hydrophobic, what is hydrophobic? The water hating part. Okay, water hating part. Only these, okay, only the negative, what do you say? Only the electronegative atom. So this will be forming the hydrogen bonding. What about the rest part? Yes, what about the rest part? If there is more alkyl chain, okay, there is more alkyl chain. So due to this presence of this hydrophobic part of that is a hydrocarbon part, the that is the interaction. Okay, there what will happen? The hydrophobic interaction will be more. Okay, so because of that, the solubility will decrease. Okay, so the benzoic acid, which is the simplest. So benzoic acid is what? This is our benzoic acid. So this is the simplest your carboxylic acid, aromatic carboxylic acid is insoluble in cold water. So it is insoluble. It is insoluble in what? It is insoluble in cold water. Then carboxylic acids are also soluble in less polar organic solvent. So the solvents which are less polar, like your benzene, ether, alcohol, and chloroform, they are slightly soluble. Okay, so this was about the solubility. Okay, this was about the solubility. So these all things you need to know. So these are the three important physical properties which are mentioned in your syllabus. Okay, is it clear up to here?
Yes, ma'am.
Okay, so let us go for the next one. That is the chemical reactions of carboxylic acid. Okay, chemical reactions of carboxylic acid. So first is reactions involving the, so what is carboxylic acid? R, C double bond O, O, H. Okay, so first we are going to see the reactions involving cleavage of OH bond. Okay, so OH. So the reaction which is involving this breakage of OH bond, so that we are going to see. So first factor is the acidity of carboxylic acid. Okay, so reaction with metals and metal alkalis. So we are going to see how the carboxylic acid, if we react with metal, so this is a metal, sodium metal. Okay, we have taken a sodium metal. Okay, and here we have taken a alkali, that is sodium alkoxide, sodium hydroxide. Okay, so how it is going to react with sodium? This is a alkali. Okay, and this is a metal, sodium metal. So how our carboxylic acid is going to react? So carboxylic acid, when it reacts with a metal, you are going to get what? You are going to get your this what? Carboxylate ion. Okay, sodium salt of carboxylate, sodium salt of carboxylate ion. Okay, plus hydrogen gas is liberated, right? So whenever carboxylic acid, when it reacts with the, so these are electropositive in nature, they are what? Electropositive in nature. Okay, so electropositive metals like the sodium, it is going to give what? You're going to get what? You're going to get a sodium salt of carboxylic ion, this, and hydrogen gas is liberated. So when hydrogen gas is liberated, this confirms that the carboxylic acid is acidic in nature. So whenever hydrogen gas is liberated, this confirms what? The carboxylic acid is acidic in nature. Okay. So whenever, so such reactions in which the hydrogen gas is released. Okay. So means what? The reaction is undergoing. Okay. It is undergoing acidic. Okay, so it is showing the, it confirms the acidic nature of carboxylic acid. Second, okay, so carboxylic acid, when it reacts with alkalis, okay, like NaOH, you are going to get what? Again, we are going to get sodium salt of carboxylic this. So Na will attach to ONA and your H plus will get combined with OH. Okay, and you're going to get water. So I got what? Yes, what did I say? So your Na plus will get combined with O minus. Okay, and you are going to get RC double bond O minus Na plus, and your H plus will get combined with OH minus, and you're going to get water. Okay, so your byproduct is water. So this is what? So whenever any acid reacts with a base, right? Our acid is what here? Okay, so you have taken a carboxylic acid and base is your NaOH. Whenever you have acid and base, you are going to get salt and water. So this is the neutralization reaction. Okay, this is a neutralization reaction. So again, we got a salt and water. So we got a sodium salt of carboxylate ion and water. So this is the reaction with your alkali. Is it clear about this reaction?
Yes, ma'am.
Okay. So next we are going to react it with a weaker base. Okay, we have a weaker bases like sodium carbonate. Okay, sodium carbonate is what? So this is sodium bicarbonate. Okay, we have taken sodium bicarbonate, NaHCO3. So NaHCO3 is sodium bicarbonate. So again, carboxylic acid, we are going to react it with sodium bicarbonate. So this test, it is used to detect the presence of carboxyl group. Okay, so this test is used for detecting the carboxylic group in organic compounds. So if you want to check if there is a carboxyl group in your compound, then you have to treat your given compound with bicarbonate, sodium bicarbonate. So what will happen if there is evolution of gas? Okay, if there is a evolution of gas, if there is bubbles coming out after putting sodium bicarbonate, if bubbles are coming out from the solution, that means what? That is the carbon dioxide gas is evolved. Means what? That means carboxyl group is present. Okay, so carbon dioxide gas will give out the carbon dioxide will give out the gas. This confirms you. This will confirm you that the compound is having a carboxyl group. Okay, so what will happen? Your carboxylic acid will form when it reacts with sodium bicarbonate. It forms salt, water, and carbon dioxide gases evolve. Okay, so it forms salt, water, and carboxylate. This is this. So what will happen? Na will combine with O minus. Okay, then you get H2O and CO2 gas. Okay, so NaHCO3, when it reacts with your carboxylic acid, you get salt, water, and carboxylic acid. Is it clear?
Yes.
Carbon dioxide gas. Okay. Any difficulty up to here? Others? So secondly, if we take a carboxylic acid and if we dissociate into water, okay, if we put it into water, dissociate means what? If we put it into water, what we are going to get? We are going to get a carboxylate ion. So if I have a carboxylic acid and I put it in water, okay, I will put it in water. Dissociate means what? It will split. Dissociate means it will split. Okay, what you will get? You will get a carboxylate ion plus H plus will combine with H2O and you're going to get H3O plus. Okay, so I'm going to get a carboxylate ion and I'm going to get what? Hydronium ion. So this is the reaction with water. So when carboxylic acid is added in water, it will dissociate, it will split up. Okay, it will split up into carboxylate ions and your hydronium ion. Okay. What is the resonance structure? We have seen this resonance structure. So if we write the resonance structure of your carboxylate ion, okay, so there is a negative sign here. So what will happen? So this negative charge, it is restabilized. Okay, you are going to get RC. So here the double bond is shifted here. Your negative charge is shifted here. So it is so again you can restabilize. So what will happen? So this is a resonance hybrid. So this is a resonance hybrid. So the negative charge can be, it can be moved. Okay, it can be moved from this oxygen to this oxygen. So the negative charge is surrounded over this particular atoms. Okay, so it is a resonance hybrid. So like this. So negative charge can be moved from this oxygen to that oxygen. So it is a resonance hybrid. So carboxylate ions, whatever the negative charge is there, that can be resonance stabilized. Okay, so this was the first property of acidity. Okay, so effect of substituents. Okay, so we will see this in the next class. Okay, because again it will be very everything will be mixed. Okay, so this much is enough for today. So in today's class, what all things we have seen, just we'll see and then we'll stop. So we have seen the methods of preparation. So these were the methods of preparations which we have seen. Okay. So after methods of preparation, then we have seen the physical properties, the three physical properties. Then we have discussed the chemical reactions of carboxylic acid. That is, the first one was acidity of carboxylic acid. Okay. So the effect of substituents, we shall discuss it in the next class. Okay. So effect of substituents. So we have left with this small part. Okay, effect of substituents on the acidity of carboxylic acid. So how if we have an electron withdrawing group, if we have an electron donating group reaction. So these all things it will be completed in next class. Okay, fine. So any doubts up to your?
No, ma'am.
Okay. Others?
No, ma'am.
Okay. Boys, any doubts? Okay, fine. So let us see the effect of substituents in the 4, 5, 6, 7. So these all things it will be completed in tomorrow's class. Fine. So if you have any difficulty, please ask the questions. Okay, go through the things, whatever I've been told. I hope you are practicing the name reactions. Okay, don't practice only for one day. Every day you have to practice all the name reactions. Okay, fine. So by this, I'll end the session here. Okay, we'll meet in tomorrow's class. Thank you. Have a good day.